Dear students, welcome back. This is our third lecture on carbonyl compounds. Myself, Rakesh Singh, Associate Professor in Chemistry, Government Degree College, Kathua, Union Territory of Jammu and Kashmir. In this video lecture, lecture number 3, we will study the physical properties of carbonyl compounds. Let us proceed. Physical properties. Properties of aldehydes and ketones. First, we will study physical properties of carbonyl compounds. First is physical state. Except formaldehyde, which is a gas, lower aldehydes and ketones are colorless volatile liquids, whereas higher members are. Formaldehyde is a gas. Others, lower one are liquids, colorless volatile liquids, higher members of smell. With the exception of lower aldehydes, which have unpleasant odors, aldehydes and ketones have generally pleasant smell. Boiling points. The boiling points of aldehydes and ketones are higher than those of corresponding hydrocarbons and ethers. This is due to presence of polar carbonyl. Due to presence of polar carbonyl, these compounds undergo intermolecular dipole-dipole interactions. ये बच्चे दिखाया हुआ है. Oxygen is more electronegative than carbon. I have already discussed with you nature of carbonyl group. It is polar in nature. Oxygen carrying partial negative, carbon carrying partial positive. So there is intermolecular, between the molecules, intermolecular interactions between the carbonyl. We call them dipole-dipole interactions. However, these dipole-dipole interactions are weaker than those of intermolecular hydrogen bonding in alcohol and carboxylic. In alcohols and carboxylic acids, we have hydrogen bonding. That hydrogen bonding is absent in case of aldehydes and ketones. Hydrogen bonding के लिए necessary condition क्या है? कि H should be attached to O, F or N. वो यहाँ है. They have strong dipole-dipole attractions, but not the hydrogen bond, which is found in, जो आपको किस में मिलेगी बच्चे? Which is found in alcohols and carboxylic acids. Hence, boiling point of aldehydes and ketones are relatively lower than alcohols and carboxylic acids with comparable molecular mass. Comparison होगा with between the molecules having comparable molecular mass. तो इनका जो boiling points है बच्चे हाइड्रोकार्बन्स और ईथर से ज्यादा होता है. They are more polar than ether, but alcohol और carboxylic acid से कम होता है. Then next, solubility. We talk of solubility. Lower aldehydes and ketones containing up to 4 carbon atoms are soluble in water. The reason is they can form hydrogen bond with water. They cannot form hydrogen bond between themselves, but they can form their negative pole, that is O negative, can form hydrogen bond with H positive of water, as shown here. Due to this hydrogen bonding, the lower members are soluble in water. However, as the size of R increases, R का size जैसे जैसे बढ़ेगा, R is non-polar, the solubility. However, as size of alkyl group increases, the solubility decreases because larger alkyl groups, being non-polar, resist hydrogen bonding. They are non-polar. They are hydrophobic. They run away from what? Alkyl group. Hence, highest member with more than 4 carbon atoms are practically insoluble. तो जिनमें 4 से ज्यादा कार्बन एटम है वो प्रैक्टिकली क्या है? Insoluble. All aldehydes and ketones are soluble in organic solvents like dissolves like organic solvents like alcohol and ether. All ether, they are also polar, as well as they are organic. They have organic part also, like dissolves like, they are soluble in alcohol and ethers. Next, reactivity of carbonyl compounds. कार्बोनल फिजिकल प्रॉपर्टीज के बाद जो इंपॉर्टेंट पॉइंट डिस्कस करने के लिए आता है वो है रिएक्टिविटी ऑफ कार्बोनाइल कंपाउंड्स. Aldehydes and ketones are highly reactive compounds due to presence of polar carbonyl in their molecules. a polar carbonyl group in their molecule. The polarity is high. The reason is oxygen is more electronegative than carbon, and there is a pi bond. Pi bond get easily displaced. So oxygen carries partial negative charge, carbon carries partial positive charge. In the presence of polar carbonyl group, aldehydes and ketones show many common reactions. Most common reactions shown by both aldehydes and ketones are nucleophilic addition reactions. न्यूक्लियोफाइल यहाँ पे अटैक करता हुआ दिख रहा है आपको. रीजन इज कार्बन कैरिंग partial positive charge. As the carbonyl group of aldehydes and ketones is polar with carbon carrying partial positive and oxygen carrying partial negative charge, इसलिए ये करते हैं बच्चे न्यूक्लियोफिलिक एडिशन. Over tens of hydrogen atom on carbonyl carbon in aldehydes makes aldehydes more reactive than ketone. Steric hindrance कम होगा H की वजह से. Presence of H, steric hindrance will be less. Hence, positively charged carbon atom of carbonyl group is easily attacked by the nucleophile. When pi electron of carbon oxygen double bond get displaced towards oxygen, the oxygen anion then picks up proton from solvent or reagent to form addition. Nucleophile will attack on the partially charged carbon, positive carbon. The pi electron get displaced, is nucleophilic attack, and we get this oxygen anion. The oxygen ion then will pick H positive from the medium, proton from the medium to give final nucleophilic addition product. The characteristic reaction of carbonyl compound is nucleophilic addition, and this is due to polar nature of the carbonyl. Carbonyl group is polar in nature. I have already discussed. Now next, relative reactivity of aldehydes and ketones. We discuss the comparison between the different aldehydes and ketones, relative reactivity with respect to each other. Then let us explain that formaldehyde is more reactive than acetaldehyde. Acetaldehyde is more than acetate. So relative reactivity of aliphatic aldehydes and ketones. First, we will discuss it. The relative reactivity of aldehydes and ketones can be explained with the help of inductive effect and steric effect. First, inductive effect. The ease with which a nucleophile attack on the carbonyl carbon depend upon magnitude of positive charge. Depend upon magnitude of positive charge on carbonyl carbon. Since alkyl groups has electron releasing effect, therefore greater the number of alkyl groups attached to the carbonyl carbon, lesser the positive charge. ये आपको समझ आ रहा होगा कि जो alkyl group है वो प्लस आई है. By releasing electron, it decreases the positive charge on carbonyl carbon. Positive charge less होगा, nucleophilic attack less easy होगा, reactivity कम होगा. So we can say, therefore, greater the number of alkyl groups attached to carbonyl carbon, lesser the positive charge on it, and therefore lesser the reactivity towards nucleophilic. So it is clear, formaldehyde has no alkyl group, acetaldehyde 1, acetone 2. It means formaldehyde will be more reactive than acetaldehyde, will be more reactive than acetone on the basis of inductive effect. Second factor which we will discuss with respect to their reactivity is steric effect. Let us discuss the steric effect. The alkyl groups are larger in size than hydrogen atom and cause hindrance to the attacking nucleophile. Alkyl groups, they are bigger in size than the hydrogen atom and cause steric hindrance to the nucleophile which is approaching to attack the carbonyl carbon. So bigger the size of alkyl group, more the steric hindrance to the nucleophile and hence lesser the reactivity. जितना alkyl group का size बड़ा होगा बच्चे उतना वो steric hindrance ज्यादा करेगा किसको, approaching nucleophile को जिसने carbonyl carbon पे अटैक करना है, lesser the reactivity. जैसे बच्चे देखें हमने यहाँ पे different aldehydes और ketones दिखाए, different aldehydes and ketones. So as the size of alkyl increases, reactivity. Formaldehyde is more reactive than acetaldehyde, more reactive than acetone, more reactive than this molecule which has isopropyl groups on the carbonyl carbon, and it is more reactive than the compound which has tertiary butyl group on the carbonyl carbon. It is causing more steric hindrance. Next, we have relative reactivity of aromatic. First, we discussed relative reactivity of aliphatic aldehydes and ketones. Now, we will discuss relative reactivity of aromatic aldehydes and ketones. In general, aromatic aldehydes and ketones are less reactive than corresponding aliphatic aldehydes and ketones analogs. This is because electron releasing resonance effect of benzene decreases positive charge on carbonyl carbon and therefore decreases reactivity towards nucleophilic attack. Now, the reactivity of the aldehydes and ketone towards nucleophile depend upon the charge on this carbonyl carbon, positive charge. Now, because of pi-pi conjugation, minus R effect of the carbonyl group, whereas electron releasing effect of the benzene ring is causing plus R effect to the carbonyl. It is releasing electron to the carbonyl. Carbonyl is exerting minus R on the benzene. So because of electron releasing effect of the benzene to the carbonyl group, what it is doing, it is decreasing the positive charge on the carbonyl carbon. Had there been no benzene here, suppose we have H here, then this would have not occurred. So this is possible only because of presence of benzene ring. So benzene ring is releasing electron to the carbonyl carbon and decreasing the positive charge on the carbonyl carbon. We can write the other resonance structures also. More the resonance structures you know, more the dispersal of charge, more the stability. So benzene is dispersing the positive charge on these resonance structures here. You see, dispersal of positive charge makes the carbonyl carbon less susceptible towards the nucleophilic attack. Therefore, decrease the reactivity. Electron releasing resonance effect of benzene results in dispersal of positive charge on carbonyl carbon and thus decrease reactivity towards nucleophilic attack. इसका मतलब साफ है कि जितने ज्यादा बेंजीन रिंग होंगे ज्यादा दो ही आ सकते रिएक्टिविटी उतनी कम। पे देखिए बच्चे बेंजीन एंड मिथाइल भी प्लस साइड से पॉजिटिव चार्ज को कम करता, इसने रेजोनेंस करनी तो अंडरस्टूड है, यहाँ पे H है, सो दिस benzaldehyde will be more reactive than acetophenone. Acetophenone will be more reactive than what? So this is decreasing order of reactivity. Note aldehydes due to presence of CH bond on carbonyl carbon get easily oxidized as compared to ketones. This is also very important. Aldehydes are easily oxidized. ये मैंने जो यहां तक डिस्कस किया, that was reactivity towards nucleophilic attack. That I explained to you. Now, one more important point I am going to explain that aldehydes, because of presence of CH bond on carbonyl carbon, get easily oxidized as compared to ketone. That is why aldehydes reduce tolerance reagent as well as Fehling solutions, whereas ketones cannot. So, towards oxidation, also the reactivity of aldehydes is more than that of ketone because of CH bond. Thus, we can conclude that aldehydes are more reactive than, हम कंक्लूड कर सकते हैं बच्चे कि एल्डिहाइड की रिएक्टिविटी कीटोन से ज्यादा है। थैंक यू वेरी मच। दिस इज माय व्हाट्सएप नंबर, यू कैन कॉल मी, यू कैन आस्क मी एनी क्वेरी इफ यू हैव थ्रू दिस नंबर। थैंक यू वेरी मच।